What's up, everyone? Welcome back to the Stats Garage for another nighttime statistics lesson. Today, we want to start to talk about the ways we can summarize data numerically. So we focus a lot on how can we display a set of quantitative data for one variable. Today, we want to start to talk about how can we summarize that data set numerically. And so we have referenced some numeric summaries, we've referenced measures of center and spread. Today, we're going to focus on a measure of position. Measures of center are also measures of position, right? Just a very specific position, the middle. So today, about a different measure of position, percentiles. So what's a percentile? Percentile, kind of for example, right? If you get your SAT score, and your SAT score is in the 99th percentile, well, then great job. And that would mean that 99% of the data values fall below your score. So for me, for percentiles, I'm always kind of thinking percent to the left if I'm picturing a graph in my head, or the percent below, right, a certain value. Right, so if I tell you that I scored in the 70th percentile, that means 70% of scores are below mine, which of course would mean 30% of scores would be above mine. All right, so that's the idea with a percentile. And on the next slide, we'll look at a couple of visual representations. Understanding percentiles is going to help us better understand what the quartiles represent in a box plot, and in a few minutes, the IQR. So Q1 and Q3, these are percentiles. As I'm pretty sure you'd guess, 1 quarter, 3 quarters, Q3 represents the 75th percentile for a data set, and Q1, the lower quartile, represents the 25th percentile. What's going on with that lag? So when we look at a box plot, the quartiles, right, are showing us percentiles. Oh, that's left over from the 700 times I started this video and never got past the first slide because I don't remember how to speak. But anyways, let's kind of jump into what was going on there. So if I just draw a box plot, random box plot, just making this up. So we now know, so Q1, right here, by definition, 25% of the data is below Q1, which of course would mean 75% of the data is above Q1. Whereas over here for Q3, right, 75%, I'm sorry, 75% of the data is below Q3, which means 25% of the data is above Q3. Now, one common misconception students have is they look at kind of this purple situation above Q3, and over here the blue below Q1, and maybe want to think that there's more data in the purple outline part than the blue. But that's not the case, right? This purple section, this is 25% of the data. This blue section, this is 25% of the data. It's just that over here in purple, this quarter, this 25% of the data is a little more clustered, whereas over here on the left, this 25%, this quarter of the data is a bit more spread out. So like the length of those arms or whatever, right? That has nothing to do with how much data falls in that interval or over that span. It's just how spread out that 25% or whatever percent of data might be. All right, so let's look at a couple pictures. So take a minute, pause the video, and I want to know what percentile does this spot represent? What percentile does this spot represent? I suppose you should have paused the video after I asked the question, but yeah, you know what I mean. And so here, hopefully we realize, right, this is the 80th percentile, this spot I've make this black line right here, or you are the 80th percentile, right? 80% of the data below, which means 20% of the data is above. And down here we've got a bell curve, so we'll see lots of stuff like this coming in the next chapter. 10% of data above this black line, so this is not the 10th percentile, this would be the 90th percentile, right? 10% of the data above, which means 90% of the data is below that value. Another thing we can connect percentiles to, which we kind of already did to some degree, like 2/5 of it. But so we've been working with this 5-number summary as we've made box plots, right? So the 5-number summary, we can do the 1var stats on our calculator and scroll down the last 5 numbers. That's the 5-number summary. Or the 5-number summary is what we see in a box plot in addition to any outliers there might be. So our 5-number summary, minimum, Q1, median, Q3, and the max. These are all specific percentiles, right? We already know Q1 represents the 25th percentile. Q3 represents the 75th percentile. What about the others? Pause the video, try to fill them in. I can picture one AP multiple choice question. It said something like, which statistic below represents the 50th percentile? And hopefully we would all recognize, right, that that's the median, the 50th percentile, right? Because the median cuts the data in half. It's right in the middle. Minimum. What percent of the data is below the minimum? None of it, right? Because if there was anything below the minimum, it wouldn't be the minimum. So the 0 is kind of like the 0th percentile. And then if we think about the maximum, what percent of the data is below the maximum? Roughly, like all of it roughly. Right? I say roughly, right? Because there might be another data value that matches the maximum or something, but essentially pretty much roughly all of the data is below the maximum. So maybe we call that the 100th percentile. And so this 5-number summary, right? These are all percentiles. These are all measures of position, right? This is like the bottom position. This is the highest or the top or whatever. This is the middle. And then these are our quartiles. What else can we do with percentiles? Let's see. Not go backwards. That's not helpful. All right. So now that we understand what percentiles are, we can actually understand what the IQR is. So to this point, we've made box plots. And so we know that the IQR is calculated as Q3 minus Q1, but we don't really know what the IQR measures. We know the IQR is a measure of spread, right? Because we just kind of listed measures of center and spread. But again, we don't know what it measures. So let's figure it out. So here we just have this random box plot, cost of lunch for the month. So we know the IQR is Q3 minus Q1. So let's focus on those values. So Q1 is right here. And we know 25% of the data is below Q1. Q3, of course, is right here. And we know 75% of the data is below Q3. So, and the IQR, right, is Q3 minus Q1, the distance between Q3 and Q1. So the IQR is from here to here. Or in other words, we can now add kind of visually, the IQR is represented by the width of the box. So if we want to compare IQRs with a bunch of box plots, we can quickly visually now know the one with the biggest box, that's the one that has the largest IQR. If it has the most narrow, right, that's the smallest IQR. But as we continue to add to this, let's think about what percent of data falls within this box. Pause the video, think about it, right? That's how we engage. And as you have now unpaused, hopefully we decided this IQR here, this box, contains 50% of the data. Why would I write with red on top of red? That seems like a terrible idea, right? 50% of the data is in this box. If we use what's here in blue and purple, right? From here to the left is 75%. From here to the left is 25%. But we only want to figure out what's in the width of the box, right? Kind of what's on this black squiggly line. Well, to do that, we got to take the whole 75%, this whole purple length, and then cut off or subtract this 25%. And so that leaves us with 50% in the middle of the box, or within the IQR. Another way we might think about it, we know Q3 has 75% of the data to the left, which means it has 25% of the data above it. Q1, we already have mentioned, has 25% of the data below. So if you got 25 over here, 25 over here, that's 50% in green on the outsides, which leaves 50% in the middle. So a definition of IQR. The IQR is measuring the width of the middle 50% of our data. So it's measuring how much spread is in the middle 50% of our data. A common incorrect written definition I see of IQR is middle 50%, right? Well, that doesn't mean anything. So, well, I mean it a little bit, I guess, but specifically the IQR is a measure of spread because it's measuring the width of the middle 50%, right? Is a half our data clustered within this area, or is half our data, super spread out? So IQR, we now know the width of the middle 50% of our data, and in some future stuff, we'll look at how this might be affected by the shape of a distribution or not. Same kind of conversation we'll have with median. That was kind of a random, unnecessary statement. Turns out I thought we should really know that definition because I put it here twice. So that must be important, or I don't know what I'm doing. So to wrap up here, a little practice. So this is an AP multiple choice question. Probably don't need this. This was me telling myself to make a video for this one. So pause the video, try this out. If you're in my class and you're going to do this through Nearpod, like in a second, this is going to pop up in front of you and like you're going to have to actually do it. So like you got to do it for real anyways. But everybody should pause it and try it. So the dot plot below, sorry, I was seeing if there was another one. The dot plot below displays the total number of miles at 28 residents, right? That's probably important. Of one street in a certain community traveled to work in a 5-day work week. So there's 28 total data values. We don't want to end up wasting time counting these dots, but if we did, we get 28, but it's all just right here, so read carefully. So we want to know what's closest to the percentile rank of a resident from the street who traveled 85 miles that work week. So nothing crazy here. Percentile rank means we want to find what percent of data is below 85 miles to work. So let's see, 85 miles, that's like here-ish. Now we may we may or may not count this dot. Of course, we could count now how many dots are to the left of 85 out of the total 28. But I don't know if I count that many, so I can see it over here. There's 1, 2, 3, 4, 5, 6, 7, 8, right? So there's 8 dots that are greater than 85, which means this must be 20. So we get 20 out of 28. And then I can grab my calculator. I know 21 out of 28 is close to 75%. So the answer should be pretty close to 75. But you know what? Why risk it? 20 out of 28. This is on YouTube. So we get 71%. Now people start to panic. They're like, oh no, 71's not there. That's why it says which is closest. And the other part of that is some people may have put this this dot over here, which would make this 9, which would make this 19. And if we did 19 out of 28, we're also going to get something close to 70%, right? This is 67%. That's our percentile. Don't overthink that. That was supposed to write 67%, but again, I'm not taking the blame for it. So percentiles. Now you know it.